9 and 7, Keith Sweat's checking you.
Bueno,
That's what I just was about to ask.
Like this?
Yes, sir.
All right. I can handle that. All right. So this is an application of the ones like this. There were several. First, starting off, actually, they start on 10. We have the one where you graph. So what you're looking for is the area underneath this curve that pertains to this. And I'm just going to do this real quick. So this is 0.5 right there. And it says to the left. So we shade over here. And then we can look up with the calculator the 0.5. And again, I'm doing this just because I want you to see the process we're going through in that application. So then this is going to be 0.6915. It's got to be rounded up. And just in case, if you worried about rounding in a rush, you can come over here and use this one, and it's already rounded. See the 0.5? See it matches. Okay. All right. So what we're trying to find is the area underneath the curve that represents what's being asked. Let's see here. All right, let's look at this one first. This is kind of the basic one. All right. So a race director is preparing for an upcoming marathon and estimates the mean time to finish is 308 minutes. All right. And then standard deviation is 54. So there's our two values that we're going to make our z-score with. So use this table or the ALEKS calculator to find the percentage of times that are shorter than 286 minutes. Now the keyword right here is shorter. And that's essentially the same thing as what we just saw in that other problem. Less. All right. Means the same thing, less, shorter. All right, so what we need to do, though, here that's different from the one that I initially looked at is we have to calculate the z-score. The z-score was given to us over there, but we're going to use the z-score to find the one for 281. So that's going to be 281. The value always comes first that you're looking for. You subtract the mean. And then we divide by 54. Okay, so let's go ahead and let the calculator do the work for us. 281 minus 308 divided by 54. So this is negative 0.5. The calculator doesn't mind if you just put in negative 0.5, but if you're looking at the table, it might help to look at it like that. All right. So since it's already selected, I'm just going to go ahead and hit that, the third one down under the recall. And then I'm going to hit equal. And so here's my value. So I'm just going to copy it and whoops, you know what? It asks for percentage. So what do we need to do? We got to multiply it by 100 because multiplying by 100 shifts everything over 2 decimal places to the right. So now this is going to be 30.85%. All right. Now I'm going to hit the undo. And again, I'm going to show you that this is the same. Some people like using the table. So see, that's it right there. 0.3085, exactly what I've got highlighted in the calculator. All right. So we're multiplying it by 100 because the calculator and the table give us the decimal value. Okay. The decimal value. See how as it gets higher and higher, see it gets closer to 1. Everything underneath the curve is 1, or multiplying by 100 gives us 100%. All right. Are there any questions about this one? I'm going to handle another one, but I just want to see if there's anything I can do to.
So it's the process is what they're asking you minus the mean divided by the deviation.
Exactly.
Okay.
And just remember, if you're using the calculator, you either use the parentheses or you do 281 minus 308 and then you divide. Because if you do 281 minus 308 and then divide 54, it'll put it underneath the 308 only. So just to show you, like I said, is if you do this and you do divide, see what I'm saying? That's why I had the parentheses on it the first time. Or you can just go ahead and do this part first and then divide. Either way will work. Because all that does is it standardizes it. And essentially, that's why they call it standard deviation. The standard deviation puts everybody on an equal footing so we can compare how they match up on that probability side. Because that's what the curve represents. It represents probability. All right, let's see what we got over here. This one's a little bit tougher. All right, so we got a biology researcher is studying the risk of extinction of a rare tree species in a remote area of the Amazon. In the course of her study, the researcher models the tree's ages using a normal distribution with a mean of 251. See, there's the mean. That's what gets subtracted from the data value. And then we're going to divide by 50. Now, use the table or Alex calculator to find the percentage of trees with the age between 187 and 229. Okay, so we're going to have two z-scores. All right, so first one is going to be, I'll just do the 229 first. That's the bigger one. And the procedure for between is to subtract the smaller from the larger. So 229 minus the 251. And then divide by 50. Let's see what that one is. 229 minus 251 divided by 50, negative 0.44. Okay. So now we got to do the other one. So the other one is 229. I'm sorry, it's 187. We did the 229 already. Subtract the mean. And then divide by 50. So 187 minus 251 divided by 50. So that's negative. All right, so what we got to do is we can do it manually or we can do it with the calculator. The calculator is basically this. I'm going to take the larger one. So this one. Oop. I don't watch that 0 because that's going to be something completely different if we did that. And then we're going to subtract, which is the smaller one. Okay, can you see what I got there? And it's a little bit kind of confusing because people kind of don't quite, they tend to think backwards when it comes to negative numbers because they are backwards. But this is the larger number, so that's why that one's come first. So see, then we got our decimal. So that's 2.2297. And we want percent. So I multiply by 100. So 22.97. All right. Now, I feel it's only fair to warn you about something because some of these, and I tried to do this to get one to regenerate and where it's got the other type here. It's like 5, maybe 8 out of 10 times you get one that says between on this. But every once in a while you get one that says less than or more than. So let me just show you how to quickly do that one if you get that. Let's see. Find that little thing. I guess I got to get it from the notes. There's a link to that thing, and just to visualize, because I want to show you what it looks like so that if you get one of those, there's an easy fix for it. So any questions about that one while I'm getting this ready? If you got anything, let me know, because I don't mind going through it to explain it. So that's what's here. It's between. So when we do between, and I'll show you both of those over here. It's way down here at the bottom. That's trying to catch up here. Oh, to the bottom. There we go. Online stat book. That's what it is. All right. So I'm going to put this one in. And it was 229, 187, and then the bigger one is 229. Okay, so that's that little chunk right there. Hold on a second, let me make sure I got it right. So 251 and 50. It's 187 and 229. Same exact thing. Now, let's say that we had one that said something like this. Let's say that it had a slight difference to it. Okay, let's say that was the question, and there will be one in there from time to time. Somebody's bound to get one. All right. So this is what we just figured out. All right. 22.97. But watch what I'm going to do. I'm going to put those same numbers down here. All right. What do you notice about those two if I switch back and forth between them? Complement. So just pay attention that if you get this one that says lower than 187 and greater than 222, then what you're going to do is you just use the complement rule. You can take 100 minus the 22.97, or let's say we'll just do it with the decimal. So let's say 70, 703. So if you get one that's worded like that, like this here, then what you're going to do after you get your answer, you can still go about it just like we did, but you got to take the complement of it because it does not want the between, it wants the outside. So watch the words, because I had somebody last night that was usually pretty sharp and they just didn't see it. Now it wasn't on their test, but it was like on the review. So they were wondering what was going on about it. All right. Does that make sense? So use the complement. Find the complement. All right. We okay? Take a look at that and just see what questions you got, because I don't want to. Run y'all off if you got questions about it. All right, we all right? You got awful quiet. Did I like do something with it that you don't understand, or is it just a matter of now you're ready? Because I can go over other stuff. We got plenty of time.
Tess, if you could just go through the review.
Okay, well that's what I was going to do, but I just wanted to see if there's anything about this just to make sure. Like I said, I don't want to leave y'all hanging in your hour of need. All right, let's go back to the review. Okay, so let's go back over to number 1. All right, so this one is the one where we count to make our frequency distribution. So we got 20 patients. All right, so when we finish all these, they should add up to 20. So let's see, 1, 2, 3. Did I get all the F's? Now let's go to the M's. 1, 2, 3, 4, 5, 6. Now the P's. 1, 2, 3, 4. So 4 P's. And then on the T's, 1, 2, 3, it looks like. And then the rest of them should be the W. So 1, 2, 3, 4. And as I said, if this is right, then you can have extra double confidence of it by just adding this up and see if they're 20. 3 plus 6 plus 4 plus 3 plus 4. 20. So good enough. All right. So now we just want to answer the question that they've got about this. It tells us the doctors are affiliated with 4 medical groups, but not every medical doctor is affiliated with every group. The table below shows the groups and doctors affiliated with them. So City Med, PTW, Bayside, MW, Plymouth, PT, Coast, MP, and W. So how many patients went to see a doctor affiliated with Coast? So Coast is right here. All right. So we're going to just go and we're going to do the M, the P, and the W. And we'll add those up for a grand total of 14. All right. Any questions on that before we get out of here or get out of this problem? All right. Let's look at the next one. Same kind of thing, except now this is what they call grouped. It's got full classes 1 to 5. So thankfully it's not too many of them because these can be a pain in the neck. And you can use the, the tallies. So it looks like there's only 1, 2. Any other ones between 1 and 5 or in the range 1 to 5, including the 1 and 5? I think that's it. 6 to 10. So there's one. So there's 3 of them. So that's going to be 3. 11 to 15. So 1, 2, 3. Four. And then looks like for this, there's only 1. All right, let's add them up. Looks like it's 10, but I'm 2 and 3 is 5, 4 and 1 is 5, but so it adds up to 10, so we got them all. So that's all there is to do on this one. Any questions about it? All right, let's go to the next one. All right, one more where we got to build the frequency distribution and then the histogram for it. All right, so same kind of thing. It helps to do tally marks. So 15 to 20. Oh, wait a minute. There's 19. Nothing else in the teens or 20. So this is going to be 3. 21 to 26. So 1, 2, 3. So 4 of those. 27 to 32. Not that one, not there, but there's one. There's one. There's one. There's one. And there's one. And there's one. So that's 6. And then the last ones, let's see. 1, 2, 3, 4, and 5. So let's add them up. Just make sure. Let's see. It's 1, 2, 3, 4, 5, 6. So there should be 18 of them because there's 3 rows of 6. Yeah. So we're done. All right. So now on this, it's just a matter of putting the number here. So this right here is going to go up to 3. 21 to 26 goes up to 4. 27 to 32 is going to be 6. And 33 to 38 is 5. We all right on that one? Anything can clear up before we leave it?
That one looks good.
All right, good. All right, so now we're getting into the calculations. For the most part, the calculator will help us for this. We got the mean, the median, and the mode, okay? Now, here's the thing is you got to watch out because they will swap these two around. Oftentimes it's mean and median, but sometimes the median's first and then the mean, and it looks exactly the same almost. It's the only thing that's different is the and is over here on the second one. All right, so the good thing about this is we can use the calculator because it'll send it over there and we don't have to worry about mistyping anything. So the first thing I'm going to do the median and the mode first, just because I think it's easier to proceed that way. Hit sort. Remember this button here, sort. All right. If they're in there with commas and you hit sort, it puts them in order. All right. So there's 9 of them. All right. So that means there's going to be one smack dab in the middle, 4 on each side of it. Now here it's 69, but we got to go over here and we're going to go. Oh, there's 239s. Okay. So here's our mode. I'm sorry, our median. All right, because then we got 4 on that side. So this would be 73. Now, since I got them sorted, it makes it easier to do the mode also. And so we just got to see what repeats. And the ones that repeat are the 39 and the 73. So the 39 and the 73. So that means that there are 2 modes. All right. 2 modes. 239s and 273s. Nothing else repeats. So since those are the repeating ones, that's the mode. All right. Now, we'll do the mean last because of the fact that I need to go in and take out the commas. Because again, I want it to do the remembering for me, I guess you could say, because I tend to, when I type things in, make mistakes, especially if I'm talking. So if I do it like this, then, oops. So 39, 39, 51, 61, 73, 73, 82, 89. So if we add them up, and then we're going to divide by 9 because there are 9 values. So 67.88888 is going to repeat. We want 1 decimal place. So that's going to be 67.9. All right. That's that's a kind of a long process for all 3 of them. But if you got any questions, I'm happy to go through.
Is there any shorter way to do this? They say we got an hour and like 15 minutes to do this.
For this, no, there's not really any shorter way. No. I mean, that took less than 5 minutes to do it. So there's not really any shorter way because you got to add up those. And I just tried to do it the most efficient way. And that's why I did B and C first. Because you, for B, you have to have them sorted. For C, it helps to have them sorted to see the repeaters. And then for the average, for the mean, you got to add them up. All right, now this is the one that takes some time here. All right. You can do the whole thing with the calculator, but it's really hard to display it. So I'll just do it the by hand way. So what we got to do is we got to have the mean. So first find the mean. So we're going to add them up just like we did. Oh. All right. We're not worried about sorting them here. Just want to make sure that they're in there right. So add them up. Divide by 6. And then we'll notice also this is a sample. So 32. All right, so as I said, the way I do this is I just kind of make a little chart. So I'm going to put each one of them here, the numbers. They don't have to be in any specific order. So there, 38, 40, 28, 20, 35, and 31. Now, from each one of these, I got to subtract the mean, okay? So what's 38 minus 32? I think it's 6, right? 40 minus 32 is 8. 28 minus 32 is negative 4. 20 minus 32 is negative 12. 35 minus 32 is 3. And 32 minus 32 is negative 1. And there's a checkpoint here. We can use a checkpoint to find out if we got everything right, because these should add up to 0 if we did it right. This is, it's crazy sometimes. It puts stuff in there, negative 12. So 6, 8, negative 4, negative 12, plus 3, negative 1. So that's 0. So we're all right. That's good. Now we got to square each one of these. So 6 squared is 36. So I'm just going to square each one of these here. 64, 16. Whenever you square anything, it's always positive. All right. So say, just to show you, so 12 times 12, see, that's where I'm getting those at. Each one of those is squared. I just happen to know what they are. 3 times 3 is 9. Negative 4 times negative 4 is 16. 8 times 8 is 64. 6 times 6 is 36. All right, now we're going to add those up. 36 plus 64 plus 16 plus 144 plus 9 plus 1. Let me double check, make sure I got everything in there. So 270, that's what goes down here. That's our sum. We're almost done. So the sample standard deviation, or S as it's called, is 270 over 6 minus 1. All right, so that's going to be 5. This is 5. So it's going to be 270 over 5. That's what they call the variance, but we got to take the square root of it. And so it's 7.35. All right, that's the longest calculation that there is. But that's it. If you want to, I'll come back and I can show you how to do it on the calculator. It's just that it's not that much easier on the calculator because you gotta, they don't have a standard deviation button, in other words, like they do for the mean.
So you get the 6 minus 1 from the number of shoppers?
Yeah, because
Okay.
it's a sample. If it's a sample, then you have to subtract 1 on the denominator there before you take your square root. And just keep in mind this. If it says population, then don't subtract 1. All right, just leave the 6 down there, in other words. But this was sample.
Oh, okay, gotcha. Thank you.
All right, so this is the where we're trying to find the percentage of students who are shorter than 61. This is just a simple counting and division. But what I'm going to do is just count the ones that are shorter than 61. 1, 2, 3. Is that all the ones that are shorter than 61? That's not. So it's 3. So then 3 divided by 12. And then that would be 0.4, I believe. 0.25. That's. But they want percentage. So remember, times 100. So that's 25%. So 25% of them.
Made it look so easy.
Well, I mean, tell me what's hard about it. I mean, you just got to
No,
count the ones. You got to count the ones that are less than 61.
Got it. Okay.
Just count the ones that fit that criteria.
Yeah.
Now, I think all of them say shorter, but don't bet on it, because if they say something like shorter than, less than or equal to, maybe, then you would count anything that was 61, or there's no 61 anyway. But yeah, you just count the ones that are shorter than 61 and divide by 12.
Mm-hmm.
You can kind of think of it. I mean, it's sort of like, if you got 12 problems and you get 3 of them right, it's the 25%.
Gotcha.
It's the kind of thing it is. All right. So this is the, where we actually got to do the percentiles. And so what we got to do is we got to sort them. But let's see here. So for this one, 25th. So what we got to do is we're just going to use it as a decimal. We're going to just do it as a decimal. And we're going to multiply times 18. So 0.25 times 18. All right. So that's 4.5. What do you do when it's with these? What are you supposed to do? you bump up, no matter what the number is that comes out, you bump up. Alex calls this method A, I believe. Although they go through and they show you, they do something like this. Instead of doing it as 0.25, they do this. And to me, that's more that kind of makes it more complicated, but they do the same thing. They multiply by 18. And then, like I said, is Schulich's fractions. So just convert it to a decimal and multiply times 18. So this is going to be 5th position. We go to the next number up. So the 5th position. Now, the same thing for 90 now. Matter of fact, I can just do it here. 0.90 times 18. So 16.2. Bump to 17. 17th position. So this is the 90th percentile. This is the and this is the 25th. So then what we're going to do now is we're going to take and we got to find that piece. Each one of those. So I'm going to send this over to the calculator. I'm going to sort them again. Remember, all the way down there on the above the 9. Now, what I got to do is find the 5th position. So, what in the world? Why does it keep moving over like that? So 1, 2, 3, 4, 5. So that right there, that 27. I don't know why it doesn't stay over there. It doesn't like this thing. Anyway, 1, 2, 3, 4, 5. So 27 is what goes here. And then the other one is 17. Now, what I'll do to make it even more, make it easier, is just come over here. 18 and 17, so go backwards. So 49 pounds. There's your percentiles. All right. Any questions? So I'll just outline the process. We are multiplying by the decimal equivalent of the 25th percent to 18, and then it's 4.5. We bump it up, so the 5th position is what we want. So we look for the 5th position in the sorted data. Same thing for this one. We do 0.9 times 18, and that gives us 16.2. So we bump up to the 17th position, and that was the 49.
Mr. Cruz,
What's up?
on that last problem, when you send the numbers to the calculator, do you start from left to right or?
Wait a minute. When I do this,
Yeah.
so you hit sort,
Uh-huh.
and then this is first, second, third, first, second, third, fourth, fifth. Once they're sorted, then you get the position of them.
Okay.
So 5th position is 27. 1, 2, 3, 4, 5. And like I said, is because you can't really make the calculator wider for us to view it. So I went over here, and since it's the 18 is the largest one, so this is the 17th position, and therefore that's the 90th percentile.
Okay.
But the only thing I do to the numbers over there is sort them. That's all I'm doing.
Okay.
All right. Now, it might help to just see a line here, because remember, this is all about that whole curve thing. So over here, this would be 100, and this is 0, and smack dab in the middle is 50%, which is also the median. All All right. Now we got the 19th percentile. So I'm going to think it's right here. That's where I'm going to put it. It doesn't have to be exact. So this is the 19th percentile right there. And then 61st would be somewhere in here. And this is enough to answer both of these questions. All right, now let's say right off the bat, we do not know what their scores were. We just know where they rank at. In other words, it's sort of like if you have a race and everybody comes in, you know their position, you know, first, second, third, fourth, fifth, sixth, seventh place, that kind of thing. We don't know their times because they're not giving us that. So now we don't know anything. So let's just see which of the following must be true. About 61% of the salespeople had lower sales than Scott. That's what the 61st percentile means. So we're going to pick that one. See stuff like this. The value of Scott's sales were about 61% of the chain's totals. We don't know what the total of the chain is sales wise. Scott is in the top half. If he were down here, he would be in the bottom half. So not that one. And Scott sold $6,100 in merchandise. We don't know what he sold. We just know his position, 61st place. So now we're asking about Gina, who was the 19th percentile, and Scott is this one. So they're not both higher than the median, right? Because one's below, one's above. Scott and Lena had sales lower, not because one's above and one's below. But this we do know. Scott's sales were higher in value than Gina's because he's way up there, she's down here. So if you draw yourself that little picture, maybe it could help you put it in perspective. All right, so we got some information that are giving us this here. All right, so we've got the mean is 36.4, standard deviation is 4.9. Now, for the normally distributed data, the mean and the median and the mode are all right here in the middle. So we're going to put 36.4. All right. Now, 4.9 is the standard deviation. So each standard deviation is going to be 4.9. So I'm going to put the mean in there. And then I'm going to add a standard deviation to it. And that brings us up to about right there. There's one standard deviation. Add another one. 46.2 right in there. And then when we get to this one, by adding one more, see, that's 51.1. You're just filling in the number line, essentially. And then the same thing's going to happen over here, except we're subtracting. So that would be right about there. One standard deviation. 26.6, right about there, and one more. So see that? 21.7 fits. So how many hops did we take? 3 standard deviations on either side gives us 99.7. That's the empirical rule. One standard deviation is 68%. 2 standard deviations is 95%. And 3 is 99.7. All right. Any questions about this? We got well, we only got one more problem, I think. Maybe 2. But if there's any questions about this one, feel free to ask. before I hit that next one. I think the next one is 11 and 12 are the same. All right. We'd already done 10, and this is the one where it's less than. Left. So let's go back. Let's go to 11 then. All right. Now this one's different because it's got two different things here. It's now got to the right. It's not left. It's to the right. So therefore, we have to do the complement. So for A, put it down here. 1 minus the probability of Z and that's what I'm going to just pop in the calculator. Let it do the work for me. Because we got to use the complement because it's right. Because the calculator and the text, that table, only give us what's to the left. So now 0.7995. It's an area, it's not percent. So watch that, don't multiply it. All right, and this is essentially the one like we just did for the application, the hard one. So this is the one, and you can do this on the calculator. You do this one first. That's the big one. And then we'll do the little one. So we're subtracting the little one from the big one. And there's 0.293, not 5, because it brings it up to 6. I'm going to copy and paste it and then change it to a 6. And there we go. All right, any questions? Like I said, this one is the same one. If you want to see another one, I don't mind doing that one, but yeah. So we're taking the test for the 7 o'clock hour. You don't have to come back. So just take your time. But if you got any other questions, hang around. We got a few more minutes. All right. You okay, Danielle?